Hey guys, this is Raghav Nakra and this is the video editorial solution of AtCoder Beginner Contest 203 which was sponsored by Panasonic. So in this we are going to discuss the first three problems, that is task A, B and C. Let's start with the very first problem, that is task A. So the first problem is that Takashi threw 3 dice and they showed 3 numbers A, B and C. If there are two same numbers among A, B and C, print the remaining number, otherwise print 0. So we can see the test cases. The very first test case shows that the numbers A, B and C are 2, 5 and 2 respectively. We can clearly see that 2 and 2 here are the same, that is A and C is the same. So we would print 5. For the second test case, we can see that all three numbers 4, 5 and 6 are distinct. So we would print 0. Also in the third test case, we can see that we are given 1, 1 and 1. That is all the three numbers are same. Still we will print A. That is there was no such restriction that all three should be same or not. If any two are the same, we have to print the third one. So I guess the question is pretty clear and simple. So what we would have to do is we were given three numbers A, B and C. So now if A is equal to B, we would print C, or if that's not the case, we will check if A is equal to C, then we will print B. If that is also not the case, we would check that if B is equal to C, we would print A. If none of these conditions satisfy, then we will print a 0. So that was all about the solution. We can just see the code. So what I did was I took three numbers as input, and if A is equal to B, what I'll do is I'll just print C. If A is equal to C, I'll print B. If B is equal to C, I'll print A. Otherwise, I'll print 0. So it is the same as I discussed in the solution. So that was all about the first question. Now let's move to the second problem. So what the second problem said was there was a hotel sort of thing and it had n floors which had numbering from 1 to n, and each of the floor had k rooms and the numbering of the rooms were from 1 to k. Now what it also said was that n and k both are one digit integers. So the numbering of the room was something like this: I0j, where I is the ith floor and j is the jth room on that floor. So they also gave an example that if it is the second room on the first floor, the room number was 102. Now Takashi, the manager, was interested in knowing the sum of all the room numbers in the hotel, and room numbers as mentioned earlier were in the form I0j, where I is the ith floor and j is the jth room on that floor. Now we would be given n and k and we would have to tell what is the sum of the rooms. So now in the example we can see that if 102 is given, which means that there is just one floor and two rooms on each floor, that is there are two rooms in total, and the sum would be 203. For the 3,3 you can have a, so for 3 we can just check is if the sum is 1818 or not. Let's have a dry run of that. Okay, so now if there are 3 rooms and 3 floors, then n is 3 and k is 3. So the room numbers would be 101, 102 and 103. These 3 rooms would be on the first floor, right? And for the second we would have these, while for the third we would have these. Since all the floors would have only 3 rooms, the numbering would be from 101 till 103, and similarly for the second floor we would have from 201 to 203, and for the third floor we would have from 301 to 303. Now if we take the total of these, then the sum would something be like 603 plus, what is this, 606, and then we would have 609, and we would just add these. We add 618 and 618. Yep. So the sum comes out to be 1818, which is the one which was given in the example. So now we can clearly see that we just need to simulate the whole process and find out the sum. So now this was all about the solution, that we just need to simulate the room numbers going from 101 to the nth floor and kth room, where each floor would have only k rooms, and by doing this we would get our answer. So the solution was pretty simple, and let's just move to the code part. So for the code, I took n and k as the input, which were given in the question, and the num variable would store the current floor, which we would need to add. And as you can see, since the number were in the form of 1 I 0 j, so I would be multiplied by 100 and then added to the final answer. So for the floor, I start from 1 to n and go till n, and for each floor we would need to add 100 into the floor number. So in the sum, I would add 100 into the floor number, and for each of the floor, since we have k rooms, so I go from 1 to k and add that room number 2 in our answer along with the floor number. The floor number is multiplied by 100 because the number is of the form I0j. Let me just show you right here also how we are doing that. So now if the room number is 105, what we would need to add is 100 plus 5. I divided the number and visualized it this way. So now what 100 is? 100 is the ith floor multiplied by 100. That is the first floor multiplied by 100. And what 5 is? 5 is the jth room which we need to add. If the number would be, room number would have been 203, what we would need to add is 2 into 100 plus 3. So that way I started from n equal to 1 to n equal to what n was given in our input, and for each of these I added n into 100 for our answer, along with adding the room number from 1 to k. That is from 1 to k I added the variable I in the answer too. So after adding all this and simulating the whole process, I returned the answer. The worst case for this would be that n is also given as 9 and k is also given as 9. So it would take us just 81 steps. That is, for each of the 9 steps, we would take 9 further more steps and add answer to that. So we would return that simply. And I hope the solution of this is clear to you. Now let's just move to the third question. For the third problem, we had 10 to the power 100 plus 1 villages, and they were labeled 0 to 10 to the power 100. And now for each of these integers I, we had to pay 1 yen, that is the currency, to go from village I to village I plus 1. What this means is we had to pay 1 yen to move to the very next village, and there was no other way to move from one village to the other, and we were forced to give 1 yen to move to the other village. That was our constraint. So now Taro, the protagonist, had k yens initially and was in the village 0, and he wanted to go as far as he can. That is, he wanted to reach the maximum I he can with the money he had. Now he also had n friends in his way who were on the ith village and had bi yens, which they will give to Taro so that he can continue with his journey. Now we had to find the last village he can reach, that is the maximum value of I, where he can reach and can't visit the next village, because obviously he would not have much money to move to the next village. So we have to tell till what village he can utilize or exhaust all his money. So that was all about the question. Let's just see the sample test cases. They have also explained us how it all went. So for the very first sample test case, we had 2 villages in which the friends were there, and they had 1 and 10 yens respectively. So now what we'll see is he had 3 yens initially. Now at max he can go is to village number 3, but we can also see that at village 2 he would receive 1 yen from his friend also. So the maximum village he can cover is village number 4. He can travel to 4 different villages one after the other, but he can't reach village 5 where his another friend was waiting to give him 10 yens, and he had to stop his journey at village number 4 only because he would have exhausted all his money and can't reach 5. And so the final village where he can reach, that is the largest village that he can reach, is the village number 4, and that's what our answer is. The explanation for this is the same as I gave. You can even read it. Now let's just see the second sample input. What we had here was we initially had a lot of money. Obviously these are way more larger than the village number. The village numbers are just 1, 2, 3, 4 and 5. And what we can see here is as soon as we reach 1, we would have 2 into this much amount, and on village 3 we would have added up all these amounts, and we can eventually reach the village number 6 into 10 to the power, how much it is, 339. Okay. So it is 6 into 10 to the power 9, and obviously the numbers can go beyond 32-bit integers. That is, we had to take long int or long in Java. And now I hope the question is clear, and now let's just move to the solution part. So now what we have, so now for the solution what we have is n and k, that is the number of friends and the number of the amount which we have before starting. So now what we will do is we will first sort the array on the basis of village number of our friends. That is, we would first want to go to a friend which had lesser village value than the one which had higher village value. And this is pretty obvious because the one who has lesser village value would also give us some money, because as we can see in the constraints that bi is at least 1, so we would at least get one amount from our friend, and it is always beneficial to visit our friend who had lower village number. So now we will sort the array on the basis of this, that the friend whose village number is lesser comes before in the iteration while going through all the friends than the friend whose village number is higher. So once we have done this, what we will do is, we will check that the amount of money that we have initially with us can take us to a friend who is very next in the iteration. What this means is, can we reach the nearest friend to us with at least k money? If we can't, we will simply return this as our answer, that is, with k amount of money we can reach at max to kth village, and we would return that we can max reach to the kth village at the first place. But if we can reach our ith friend, we will add up the money which he will give us to move further, and now we will use this as a new k to check further that we can reach our very next friend after this or not. That is, can we move to friend I plus 1 or not to take its help or gain money from him. So that was all about the solution, that we start from the very first friend and check that whether we can reach this friend or not, and if we can, we will take the money from this friend and move further to the second friend and so on. And the very moment we can't reach our ith friend, we will stop here and return the amount of money that we have collected total. Why we are returning the amount of money that we have collected till now is because if we have collected k amount of money, we can at most reach kth village, and that is what we had to tell. So that was all about the solution, and now let's just move to the code part. So now for the code, what I did was I took n and k as the input, which were the number of friends and the amount of money which we initially had, and I took vector of pair long. This vector of pair long VPLL indicates vector of pair long, and I took this as my input and then sorted the whole array. And once I did this, as I explained, I did this because I need to go to a friend with lower village value than the one who had higher village value, because it is always beneficial to consider our friend who is nearer to us than the one who is not. So now I took answer variable and index variable. This index variable indicates the very next friend which I need to go. This index variable indicates the very next friend to whom I have to go, and now I'll iterate through all of my friends' house. That is, I'll check till the time I haven't gone through all of my friends, or if I can't reach to my next friend. Currently our answer variable stores k, that is the farthest house we can reach till now. But what this condition shows us is that if the village of the very next friend is having value less than the farthest village we can reach right now, then we'll break out. But if that's not the case, we'll add the money that our current friend gave us and move to the very next friend, or search for our next friend, that whether we can reach that person or not. And in the end, we'll just simply return our answer that we stored. The answer was the maximum money we collected, or in other words, the maximum village we can reach starting from the 0th village. So that was all about the code. I hope all the solutions are clear to you. So now that was all about this video.